Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on remove duplicates from sorted array. The problem states that we are given a sorted array and we need to remove the duplicates in place. In place means we should not use any extra space to create a new temporary array to perform the operation such that each element appears only once. The order of the elements should be kept same, and the first k elements of the numbers should contain the unique numbers and the remaining can be ignored. So the brute force approach would be we can create a temporary list or an array and we would be adding all the elements if they are not already present, and we will copy them back to the original array. For that, let's initialize a list. Say list and for each number in the given array we would be checking if the list already contains it. If it does not contain, then we would be adding it to the list. And after this, we would be getting each element and we would be updating the original list. So we need to return the number of unique elements. So the list already contains unique elements, so we can straight away return the size of the list. Let's run the code. It is working, but this violates the space constraint because we are already told that we have to do this in place, which means we cannot use any extra space. But since we are using this is violating the space constraint. But to help us understand the problem, I have returned this code. And and the time complexity would be O of n square here, because this for loop takes O of n and this method contains itself takes O of n time to check if the number is already present in the list. So the time complexity would be O of n square and the space complexity would be O of n because we have used extra space in the form of list. Now to optimize this, as we are already told that the given array is sorted, which means the duplicates are adjacent. Now we need two pointers where pointer I keeps track of the last unique element and pointer j is used to track it is used to scan the whole list. When the elements differ, we will move I and we would overwrite it. And the code for this goes like, let's consider one pointer I at 0, which is used to keep track of the last unique element, and we would be taking one for loop where it is starting from index 1 because I is at index 0, and we would be iterating till the end. Now we need to compare the two elements present in I and j indices. So for that, if nums of j is not equals to nums of I, which means they are different. Then we would simply increment I because it is unique, and we would overwrite nums of I with nums of j. At the end, we would be returning I plus 1. Because I is an index and it starts from 0, so the count would be I plus 1. Let's do a dry run to help us understand better. For example, if the given nums is 1, 1, 2, 2 and 3. Initially I is 0 and j is at 1. So I and j are equal. That's why it will not enter this for loop. So we will be incrementing I, and in the next iteration j will be at 2. So this 1 and 2 are different. So we would override nums of 1 with nums of 2, which is, we would override this 1 with 2. And in the next iteration, j will be moved to this index, and we will be checking if they are equal. So 2 and 2 are same. Then j will be moved to 4. 2 and 3 are different. So we would be replacing this with the j value, which is 3. Now the first k elements are unique. So the size of this, now I is at this position, which is at index 2. But the total number of elements are 3. That's why we would be returning I plus 1. And as it is already told that we can ignore the remaining elements after this. So we can ignore 2 and 3. And the unique elements are 1, 2 and 3. So the time complexity would be O of n because we are doing it in a single pass, and the space complexity would be O of 1 because we did not use any extra space. So since the array is sorted, I used 2 pointers to override the duplicates in place and return the count of unique elements. That's it for today's video. In the next video, we will be working on valid palindrome. Thank you for watching.